Okay, number 36 says if m equals 3 and n equals 5, what is the value of 4m plus mn? So obviously this is a substitution one, so we're going to write 4 instead of m. We know m is 3, so we're going to replace it with 3 plus 3, which is m again, and n, which is 5. So let's go ahead and figure this out. Of course, when a number is touching a parenthesis or parentheses are touching each other, it means multiplying. So here we have 4 times 3, which is 12, plus what 3 times 15 is, which is, or 3 times 5, which is 15. So we have 12 plus 15. That is going to equal 27. And my answer is B. 37 says, which operation will change the value of any non-zero number? So in case you don't know what a non-zero number is, a non-zero number is just what it sounds like. It's any number that is not zero. So I'm just going to pick a random number. I'm going to pick 7. So 7 is my non-zero number. So it's saying which of these 4 things over here, the answers will change the value of it. So here we go. Let's go ahead and do A. Let's add 0 to it. So 7 plus 0, because we're adding 0, we know that equals 7. So as you can see, the value stayed the same. The 7 is still a 7. How about B multiplying by 0? 7 times 0. Well, we know any number times 0 is 0. Hey, look at that. 7 now changed to 0. So I think it's B. Let's go ahead and check the other ones just in case. 7, C says multiply by 1. 7 times 1 is 7, so it stayed the same. How about 7 divided by 1? That is also 7. So our correct answer is B. Multiplying by 0 is the one thing that changes the value of any non-zero number. 38 says, which property is used in the equation below? So we're looking at this equation down here. So let's go ahead and look at 12 times x plus 4 equals 12x plus 48. So when you get a problem like this, you have to look at the answer over here. So you have to figure out how did we get 12x plus 48. So we know that we can add right here. We cannot add x plus 4 because we don't know what x is. So the only real thing we can do is multiply 12 into x and then 12 into 4. We got to break these people out of the parentheses. So we're actually going to go 12 times x, which gives us 12x, and 12 times 4, which gives us 48. So we knew this. We know how to do this. But what is this called? Well, let's see. Is it associative property of addition? No. Is it commutative property of addition? No. Is it distributive property? Yes. Reflexive property, I don't even know what that is, so I don't think so. But distributive property is what we use to figure out this, and it was really easy to figure out because of what our answer was. When it gives us the answer, then we know how we got that and how we should have gotten it. 39 says, which expression is equivalent to 3x minus 3y? So for this one, I use this method. Whenever I'm trying to figure out equivalence, I always try to think about, well, what if x was a number and y was a different number? So I give them values and then I try to figure out which one of these is the same value, which one of the answers. So for example, like x, I'm going to make it 2, and y, I'm going to make it 1. So 3 times x, or 2, is 6, minus 3 times 1, which is 3, equals 3. So I'm looking for something with the answer 3 if I substitute x with 2 and y with 1. So let's go ahead and do this. X is 2, y is 1. So 3 times 2 times 1 is 6. All right, that's not the same as 3, so I don't think it's this one. X is 2, y is 1. So 2 minus 1 is 1. And 3 times 1 is 3. Okay, might be this one. Might be this one. Let's check and make sure. Here we have 3 times x, which is 2. That's 6 minus 1 is 5. It's definitely not this one. X is 2 minus 3 times 1, which is 3. So 2 minus 3 is negative 1. So, okay, as you can see, it's B. That is the way I do it. That's a really easy way to do it, to figure it out. And if you know another way, I'm sure there's tons of other ways. So to me, this is the easiest way, and hopefully it works for you. All right, number 4 says, which of the following equations illustrates the inverse property of multiplication? So inverse property of multiplication means that pretty much the way we learned it was that it was flipping something. So let's say we have a number like 7. If we were to find the inverse of 7, we'd have to flip it. Now, usually it'd have to be in fraction form. So first you have to turn 7 into a fraction, which we know we turn any number into a fraction by putting it over 1. Then we flip it. So 1 is now the numerator and 7 is the denominator. So this is the inverse operation, inverse property of 7. So now let's look over here at the answers and see which one it is. So as you can see in B, C, and D, there's no fractions. Where right here in A, you have 1/5. So what this was, how we know that this inverse property of multiplication is that before this was 5 divided by 5 equals 1. And so what I did was when I flipped it, when I flipped 5, it also flipped the signal, this operation. So it's 5 times 1/5, which is also equal to 1. So this is a good example of inverse property of multiplication. Number 41 says, which equation shows the distributive property? All right, distributive property is pretty simple. It's numbers, one number that breaks a lot of other numbers out of parentheses. So let's go ahead and look and see which one it's doing. As you can see in D, D doesn't have any numbers that can break it out. The way I remember teaching you guys this is that, let's say you want to have 12 break out 4 and 6. Well, 12 cannot break out 4 and 6 because it can jump over the parenthesis, but it cannot jump over two things like the plus sign and the parentheses. So that's not going to use distributive property to solve that. Number C, the answer C is the same thing. There's no numbers touching the parenthesis. Same thing with B. No numbers are touching the parenthesis directly until we get here to A, where as you can see right here, we have 4 touching the parenthesis directly. That is a very, very good sign that you will have distributive property. So let's figure it out. So if we have 4 jumping over to break 3 out, that's going to give us 12. And then 4 times positive 6 is going to give us positive 24. So our answer is A. It's a very good representation of what distributive property is. 42 says, which expression is a result of applying the distributive property to 8 times 100 plus 5? So remember I told you earlier that you could not use distributive property if your number had a jump, if your number was not touching the parenthesis. Well, as you can see right here, this problem is not touching the parenthesis. What's actually touching the parenthesis is the multiplication sign. But this is kind of a trick question because as you know, when a number like 8 right here touches the parenthesis, you know it's multiplication. So this multiplication sign doesn't really need to be there. It could be written this way and it'll be the same exact thing. And we're used to it being this way. I don't think you've ever seen one where it has the multiplication sign like there because it's pretty much saying 8 times 8 multiplied by multiplication of 100 plus 5. So it kind of has 2 multiplication signs in there, if you will. So it's more written like this. So let's go ahead and do that. So 8 times 100 is 800 plus 8 times 5, which is 40. And if we do it that way, if we use distributive property correctly, we know our correct answer is D. 43 says, which property is illustrated by 1/2 times 3 over 3 equals 3 over 6? So the first thing we want to do here is make sure the work is done correctly. So 1 times 3 is 3, good. 2 times 3 is 6, good. All right, so now let's look and see what property it represents. So additive identity, well, first of all, it's not adding, so that's really easy to see that that one's not it. Commutative property, so commutative, remember, sounds like commutative, so that means to talk. So can 1/2 talk to 1/2 over here? No, there's no 1/2 over there, so it's not that one. How about distributive property? No, we don't use distributive property for this problem. Multiplicative identity, well, we do have multiplication, we do use multiplication here, but we do not have identity. Remember, identity is when you do something to a number, like let's say 1/2, and it ends up being 1/2 over here at the answer, so that's not it. Okay, so as you can see, we didn't pick any answer, so we made a mistake somewhere. So let's go back and let's try to figure out where our mistake was. The best way to figure out where our mistake was is always go back to the basics on this one and make sure you did all the steps and all the steps in the problem were done correctly. So 1 times 3 is 3, we got that. 2 times 3 is 6, good. But remember, there is a last step in fractions. Any fraction problem always has the same last step, which is simplify or reduce. So can 3/6 be reduced? I think it can. I think we could reduce it by 3, divide it by 3 each one. That's going to give us 1/2. So instead of 3/6, it's more like 1/2 times 3 over 3, which is really just 1. equals 1/2. Okay, now that changes a lot because now as you can see here, we have 1/2 over here and we also have 1/2 as our answer over here. So now this is an identity problem, and we know this because 1/2 is on both sides. Something happened, a function happened to 1/2, and it still ended up being 1/2. That means it's an identity problem. So let's go back. Commutative properties, still not that, because like I said, it was an identity problem, so it's not these two. Now, additive identity, did we add to get the same thing? No. But did we multiply it to get the same thing? Yes, we did. So the correct answer is D, multiplicative identity. 44 says, which property is illustrated by 4 times 4x plus 4 equals 4x plus 8? So once again, you have to look at the answer and see, hey, how did I get this answer right here with the problem I have over here on the left? So let's go ahead and figure it out. So how did we get 4x? Well, I think we did 2 times 2x, which would give us 4x, good. And then 2 times 4 would give us 8. Once again, this is our good old friend, distributive property. These should be really easy for us by now. All right, 45 says, which of the following is an example of an inequality? All right, hopefully you guys know what an inequality is. An inequality is the use of any symbol that is less than, greater than, or less than, greater than, or equal to. Those kind of symbols are inequalities because they tell you what it's not equal to, not what it is equal to. So that being said, an inequality is not anything with an equal sign in it. So it's not this one. It's not this one. This one's just a subtraction problem. So B is your correct answer because remember, an inequality has a greater than, less than sign in it, something along the lines of that. That's what inequalities are. All right, 46. 46 is a big one. Let's go ahead and see if we can get this one bigger because we're not going to be able to see anything if we don't get it bigger. Okay, so 46. It says, the table below shows the, let me zoom in a little here. The table below shows the charges for rent and racing a go-kart. So I guess if you do 0 laps, so if you just want to rent the go-kart to look at it, I guess, it's going to cost you $5. If you want to do 1 lap, it's $8, 2 laps, $11, 3 laps, $14, 4 laps, $17, 5 laps, $20. So it's saying which graph best represents these prices. Okay, so the best way to do this one, for me, I find, is to go ahead and plot these points out on all these graphs. So let's go ahead and do the top two since only see those right now. So I'm gonna go ahead and pick red so you can see it. So let's plot 2 points because it'll be much easier. We don't have to plot all of them. Let's plot 2 points. And I always like to do the first and last one when I'm plotting points. So if x is 0, y is 5. So x and 5 right here on the first one. So I can already tell you it's not this one. I'm gonna actually cross that one out right now because that's not right. So here we go. 0 and 5. All right, it's not this one either. So it's not A or C. Let me scroll down a little. Let me see. So here we have 0 and 5. Good. And here we have 0 and 5. Okay, so it's not this one either. It's not B. It looks like our answer is D, but let's make sure. Let's make sure it is D by scrolling back up. Our last point is 5 and 20. So let's make sure it matches up with 5 and 20, and if it does, then we're good. So 5's down here, 20 up here. Hey, look at that. Both of these points are on this line. Our correct answer for this one is D. It is the wading pool. So which statement best describes the water levels of the pool from 2 p.m. to 3 p.m.? So let me see. From 2 p.m. is right here. So I'm going to go ahead and mark it right here. And to 3 p.m. is right here. So as you can see, I'm going to put a little dotted line here so you can see that I lined it up with the appropriate times that said in the description right here. So as you can see, the water levels are going down. So let's go and see. The pool is empty. Well, it's not exactly empty because it shows it has water in it. The water level is consistent. Well, not really that because it looks like it's actually going down. Is it increasing? No. It is decreasing. All right, so the correct answer is D. Okay, this one says, which expression below has the same values of x to the third power? So for x to the third power, remember for exponents, the exponent tells us how many times we're multiplying the base. by itself. So for example, for x to the third power, it means that we are multiplying the base, which is x, to itself however many times the power is, which in this case is 3. So it's going to be x times x times x, which means that our answer is going to be C. 49 says which expression is equivalent to 8a to the 6th power divided by 2a to the 3rd power. So for this one, we've already done some where we're doing the variables with powers, but we haven't done one where we have numbers and variables. So let's go ahead and do this one. It's kind of a two-step process, and as I write the problem down, you'll see what I mean. The best thing to do is to do the numbers and then the variables separately. So first, let's figure out how many times 8 divided by 2 is, or how many times 2 goes into 8, which is 4. Now remember, when we have exponents and they have the same base like they do here, which is a, that means that we are going to subtract if it's division. So here we have 6 minus 3, because those are the exponents, which is 3, which means that our answer is the same base, which is a to the 3rd power. So my answer in this case is 4a cubed to the 3rd power, which means it is D. All right, last one for this one. It says, which graph shows y equals negative x squared? So remember, when we talked about parabolas, which all these here are, the reason you get a parabola is because you use a square. That's what forms a parabola, because if you have a negative number times a negative number, it's always positive, so you'll never have any negative numbers that are part of y. So for this one, we have to understand the rule that if you have a positive x squared, that the parabola is going to open upward, which means the arrows are going to be pointing upward. And if you have a negative x squared, the parabola is going to be opening downward, which means the arrows are going to be pointing down. I don't really know if we've learned the parabolas that are sideways like these two, like B and D, so we're just going to cross those out because I don't think we learned them. But we know that if the x is positive, then it'll open upward. If x is negative, it'll open downward. So in this case, if you could see right here in the question, x is negative, so that means it's going to open downward, which means our correct answer is C.